Okay, let's look at the equations of functions. All right, so here's the question. Do the following equations specify y as a function of x? All right, to answer that question, we have to make sure that for each x value, you get exactly one corresponding y value. All right, so in order to check that, I'm going to just isolate y from this equation. All right, so first thing is I'm going to try to get rid of, so I'm going to try to move x to the other side. We can do that by subtracting x from both sides. Right, so we get negative y squared is equal to, right, so negative x plus 1, because 1 was already there, right? Then I would like to get rid of the negative sign there, so we can just divide or multiply. I'll just do multiply by negative 1. Right, so we get y squared is equal to, right, negative x multiplied by negative 1 is positive x. Positive 1 multiplied by negative 1 is minus 1. Right? Then we can get rid of this square by taking the square root of both sides. Right? So take the square root of both sides. Right? But we have to be careful. Whenever you take the square root of both sides, we have to consider positive 1 and a negative of square root of x minus 1. Right? So you notice that there are actually two different formulas, the positive version and the negative version. So I'll note that there are two separate formulas. All right, which indicates that this is not going to be a function, since, for example, say let's try x equals 1, right? Right? Then the corresponding y value is going to be, there are two values, right? The positive version would be positive square root of, right? Plug in x equals 1, so 1, actually, sorry, let's try x equals 2, right? So it's going to be 2 minus 1, so that's going to be just positive 1, because positive square root of 1 is square root of 1, right? There's a negative version of that, which is negative square root of 2 minus 1 is negative 1, right? So you can see that you can kind of visualize it. So you have, say, here's a domain, so there's 2 in it, and here's a codomain. Let's say there's a positive 1 and a negative 1, right? 2 is mapped to both positive 1 and a negative 1, right? So you can see that this is not a function. So this is not a function, right? Which means that the answer to that question is no, right? This equation does not specify y as a function of x, right? How about the next example, right? So you have an equation here. So the same step. What we do is we're gonna collect. Let's see. I'm gonna put these two guys together. So these two guys together, right? So y is in common. So I'll factor out y, right? So from here you have x, right? So from here you have 1. So x plus 1 times y. Right, and I would like to move negative x to the other side, so I'm gonna just add x to it. So this is going to be simply so x plus 5. Right, then we want to isolate y, so I'm gonna just divide through by quantity. So divide through by quantity x plus 1. Right, so x plus 1 cancel out, so you have a y by itself, right? So you have x plus 5 over x plus 1, right? So you can see that this is a single formula, single. right? Since a single formula only produces one corresponding value, so therefore this guy is a function. So y is a function of x. So answer is yes. Right? So if you're trying to see if the equations specify y as a function of x, so all you have to do is solve for y. If you have multiple formulas, then answer is no. And you solve for y, and if you have a single formula, then answer is yes. Y is a function of x. All right? That's it. I hope that this was clear.